Today's math lesson is Chapter 4, Lesson 6, Mixed Numbers and Improper Fractions. And the first thing that we're going to do is get a couple definitions down. We're going to get a couple definitions. Actually, first what I want to do is talk about our objective. Our objective is our objective is that I will be able to write a mixed number as an improper fraction. That is what you will be able to do at the end of this lesson today. So the first thing we need to know for the lesson is we need to know what is an improper fraction. So an improper fraction is a fraction where the numerator is bigger than the denominator. An example of that would be like 7/5. Remember, 5 is the denominator. Denominator is on the bottom. 7 is the numerator. Numerator is on top. So in an improper fraction, the numerator, the number on top, is bigger than the denominator, the number on bottom. So a proper fraction is one where the denominator is bigger than the numerator. For example, if we flipped that and did 5/7, that would be a proper fraction. And what I forgot to add in improper fractions is if the numerator is equal to the denominator, for example, 6/6, that is also improper. And the reason that that's improper is because 6/6 is equal to 1. So, those are the two things you need to know for this lesson. So one important principle that you need to know about fractions is when you look at fractions, remember the numerator is the number on top and denominator is on the bottom. What the denominator means in a fraction is how many pieces did you split that whole into. And the numerator means how many of those do you have. So let's start taking a look at a couple different fractions. Let's first look at the one on the left, 5/4. What that means is that the whole is split into fourths. Each whole is split into 4 pieces, and we have 5 pieces. So what we need to realize is that means we have 5 pieces when the whole is split into fourths. So that means we have more than one. Whereas if we have 3/4, it's still split into fourths, but we only have 3 of them. So 5/4 is an example of an improper fraction. And it's improper, and that means it is more than 1 or equal to 1. And this one is a proper fraction, and that means it's going to be less than 1. Because if you have more pieces than it's split into, then that means you must have more than 1. And here's an example of when the numerator is equal to the denominator. And you see, if we fill this in, the whole is split into 5 pieces, and we have 5 of them. And the reason that would be considered an improper fraction is if it's split into 5 pieces and we have all the pieces, then what does that mean? That means we have one whole. So anytime ever in the history of your life when you see a fraction that is 5/5, 6/6, where they're the same, 3/3, 23/23, you should know that is equal to 1 when the numerator and the denominator are the same. So what I'm going to show you how to do next is how to switch from improper fraction to a mixed number, and then I'm going to show you how to go from mixed to improper. So let's first look at an improper fraction, how to turn it into a mixed number. Let's start with 5/3. So when we look at 5/3, what that means is this drawing. We have 5/3. So that means we have 5 pieces that are split, 5 pieces when a whole is split into 3. So each one of these is a whole, and they're split into thirds, and we have 5 of them. So what you see is we have 1, 2, 3, 4, 5. So what that means is we have one whole here, and then how many holes do we have left? We have 2, thirds left. So we took out the 1 whole there, put it right there, and then we have 2/3 left. So 5/3 is equal to 1 2/3. So we've just changed a improper fraction into a mixed number. And the trick to be able to doing that without the drawing is you know that this bottom number tells you how many the wholes are split into. So what you have to do is you have to figure out how many times does 3 go into 5. Well, 3 goes into 5 1 whole time. And so if we take 1 whole out, that means we're going to take 3 pieces out. Because remember, 3 pieces would be 1 whole. So we took 1 whole out, and that means we took 3 pieces. So we had 5 total pieces, and we took out 3, so that's going to leave us with 2 left. So we're still left with 2/3. So that's the other way that you can get to the answer, 1 2/3. Now I'm going to show you another example of how to do it that way. Before we start this problem, I want to challenge you to see if you can tell me what fraction that, or what improper fraction does that represent. Pause and write that down. Okay, so you can see that what are we splitting each whole into? We're splitting each whole into 3, so 3 is our denominator. And how many do we have? We have 1, 2, 3, 4, 5, 6, and 7. So, what you can see is that 7/3 is equal to 1, 2, and then we'll take 2 wholes out, and then we're left with 1/3 left. In order to do that the other way, we could do 7/3. How many times does 3 go into 7? It goes in 2 times, 2 wholes. And so we have pulled 2 wholes. Remember, 3 is each whole is split into 3. And I took 2 out, so that means I took 6 total out, and that leaves me with 1, so that means I have 1 left, 2 1/3. Is that as a mixed number? Let's try one more here, and you can either draw it out or you can just solve it. So I want you to do 11 halves as a mixed number. Pause and solve. Okay, you could have drawn it, or you would have to just solve it the way I showed you. How many times does 2 go into 11? 2 goes into 11 5 times. So that means we have 5 wholes. We pulled 5 wholes where each hole is split into 2, so that means we took out 11, and we would have 1 left, 1/2 left. So our answer would be 5 1/2. Now I'm going to show you how to go backwards and do the same thing the opposite way.